Hello,
Hello?
how are you?
Oh yeah, I'm pretty good. I just using a new computer because my computer was
Ah,
in yeah.
can you see my whiteboard?
Yep, and I can write as well. I've got the same writing pad. I
Oh,
can
good.
write.
Oh, good.
Yeah.
Okay. Now, what shall we talk? The assignment or your trigonometry?
Probably I'm close to finishing, but I think we could do some trigonometry today. And then next
Okay.
week do the assignment because I'll be fully done by then. I've done around 85% of it,
Oh, by the
around that
way,
much.
before we go, we do. Can we just tell me what is your general formula for this? I just make sure because I have tried to work out this general formula,
Yeah.
which give me a slightly different formula from yours.
Yeah.
My result is slightly different. Can you show me what did you get? This is a general formula. This is just the formula, right? How to find the formula for any term? I think it's
Mm,
negative one, n plus or minus something.
yeah, it's plus plus minus minus. We didn't get a formula. We just got this. We just got this series.
Do you need the formula?
Oh no, I've got the formula. We found a way to change it.
Now, my question is, how do you know
Right.
how to obtain this general formula? If you call this a T1, the term one, and this is
Oh
term two, how to find this? So this is two, right? And then it go to positive again.
yeah.
This is a pattern here. You get two positive and two negative. Then two positive, two negative.
Yeah. It's like a double alternating. Yeah.
Now, did you have any formula? I remember you told me something like a negative one n
Oh
minus
yeah.
half. What did you do?
We got
Basically, we're looking for the formula for Tn.
yep. Oh yeah. So TN.
Mm-hmm.
Hmm.
Can you write from
TN.
Can you
Oh
write from your side? I just
yeah.
watch how did you how did you
Like you
do?
mean like pi? Yeah, yeah. Like let me try and write this in the option.
No.
So yep, okay.
So basically, we are going to rewrite this formula as this, okay? We are going to write this as a sum of the Tn. So this is Tn, and
yep,
n from 1 to infinity, all right?
yeah.
So what is the formula for T1? Or what is the formula
Oh,
for Tn?
okay. T
Do you
yep,
have the formula?
equal. Yep.
Okay.
I'll write it. Negative one to the
Okay.
power of one plus n over two round down over nc2.
Is that simple as that?
Yep.
Now, if you want to say T equal to 2, what will we get? Say, we know T equal to is this one. How is T? Oh,
T to
I don't
power.
know. Did you group that? If you just, or do you call this T1, T2? Or,
Yeah. Well, oops. Sorry. Let me just erase
mm-hmm.
that. Yeah, I think the first term is yeah, we can consider the individual terms. If you put in
Yeah.
um it has to start at n equals 2 because you can't do 1c2
Ah, n
like
from 2.
yeah.
Okay, so you get n
Yeah.
from 2. Okay. So say when how about n equal to 3, for example? Do you have 3?
Yep. So when n equals 3 that means
So they got
t3
negative 1. You got 1 plus 3 over 2, right?
yeah.
So what is the sign for 3 over 2?
It's round down like so it's negative 1 to the power of 1 plus 1 because it rounds whatever is in the bracket rounds downwards. So you got
No such notation. No, you can't tell mathematician this is a.
Oh,
What
we
do you
got
mean?
it off a. It's like we found it off a Swedish professor. He came
Yes.
up with this formula. But, you have to the bracket is round down. It's in Excel as well. It's like an algorithm to
It's
round
not.
downwards.
It's not. It's just notation. So they're trying
Yeah.
to avoid. In this way, they're just trying to avoid using the fraction, right? So whenever they see this 3/2, what does they do? When they run down, they just change it to the 1 or what?
Yeah, 1. That's how you get the double alternate, because then you get -1 to the power of 2 over 6 over.
I think it's a little bit silly.
Yeah.
How do people
What?
know? So also this one also happen to this one. Do you agree? When this happen, what do you get?
2.
You got 2?
Yeah. That's how you get the double though. It's like plus plus
No, no,
minus
no, no.
minus.
You mean? Can you show me? Actually, I have implied. There's a better way to get the proper notation here. Can we just put?
Is there?
Can we group? Yes. Can I show you? Can we group them together? Can we group them? So
Yeah.
this can we group this as a term 2? All right. This is way different way to count how to count it, right?
Yep.
So in other words, can we just clean up what you write? Okay, do some.
Let me just clear.
Okay.
Yep.
All right. Okay. So basically, what I can do is that in this way, if we just follow my notation here, we got that Tn. We just from this first beginning, we just from the first T1, we're looking for the pattern. In this way, T1 will equal to 1 over 2 is a combination formula, right? Plus
Yep.
2 plus 1. You see? This is
Yep.
combination formula. And T2 will equal to negative. You see, equal to negative. That would be, because we call it 2 now, so that would be, can we call this T, this, how to say this, 2 times 1, 2 times 1, 2 times 1 here. So that would be, let me see, how did I get this formula? So that would be, can we just write down first, okay? Let's write down first. That is 1 over is 4, 2 plus. Can you see? I put a negative sign here now. I put a negative sign here, right? That would be the 5. That would be 4 plus 1. See, 4 plus 1. Can you see? 4 plus 1, C2. Okay. Now here we do something. Can we call this one? Can we call this is negative 1? Negative 1. Now how to make it negative? It must be even number, right? So it must be because we're end up with this is n equal to 2 now, right? This n equal to 2, this n equal to 1. Okay.
Yeah.
Since that to be, can we rewrite 2
N?
plus 1 plus 1? No,
Okay.
just plus 1.
Yeah.
I don't like fraction. I think it's very silly. I don't like fraction. The fraction is not very. It's not analytical. You have to kind of to ask people to memorize or to follow the new rules. You know, the less the rule, the axiom, the better. Okay.
Yeah.
We don't create that new axioms. What we have left? So we have to rewrite this inside. So the first term, because it's got 4 here, can we just say 2 times 2? C2, all right?
Yep.
And this one, that will be 2 times 2 plus 1. Can you see? Can you see the pattern now?
Oh, okay.
Can you see the pattern now?
Oh,
so
2 times.
So when n equal to, so we will see the pattern now. So when n equal to n, okay, n equal to n, then we got this formula. So n will equal to -1. See, that will be n. Because n plus 1. Okay, simple. They alternate every 2 term, right?
Yeah.
So what inside got 2 term here? The first term is. Can we keep the 2 there? We keep 2 here and put n here. So that is general formula. And this, can you see the general formula now?
Yep.
That is 2n plus 1 C2.
Oh, okay, yeah.
Can you see? That's general formula. you don't have to dealing with this fraction.
But
Yeah, go on. Do you want to try
what,
any?
oh, it's just that because in my case, I need to consider like every single term individually, because each one is like a summation. So like that's why we had to use the round down formula, because like you have to consider each one individually, because this is in groups of 2, right?
What do you mean do you have to? What do you mean
Like,
you have to?
because we're comparing so we have formulas to find the value of pi, and we've given the domain.
It's not a formula. It's a series. You see?
Yeah,
It's a
yeah.
series.
But like yeah, sorry. Yeah.
So you mean you can't do with this formula? You can't do anything with this formula? I think this formula will be give you simplified, because it doesn't matter. You count every 2 term, or you count even every 4 term. That is okay, because you know what? Look at this number. This is infinity. Okay, it doesn't matter. You count a single term, or you count a group of numbers. Doesn't matter. Group of elements.
Oh, I guess that's fair. Yeah. Oh, okay.
It's elegant. It's more compact. Who cares? Who invented the notation? No matter what the professor is, how can they say they equal to 1? It's too much to learn.
Yeah.
Now, if you use this Excel, can you actually can you find the formula? Because it's the same. Because in your formula, what's your formula? You still need to calculate this combination. Do you agree?
Yeah.
The only difference is that we can this is a sum of 2 combinations, right?
Yeah.
So if you can use Excel to write this part, then you should be able to write the sum of 2 terms.
Okay, yeah.
Because in this way, I don't make any assumption. We don't have use any new notation or new rule or new axiom.
Yeah.
Do you want to use this formula in your report, in your assignment?
I'm not sure, like, because I've already done like I've already used the entire the other formula for like my entire assignment, and it's already in my graphs and stuff. Like, I've got like because we're figuring out the value for n at which the approximation of pi is equal to the 11 rounded decimal places.
Just finish his talk. So what's your to achieve your accuracy of pi?
Yeah.
Okay, what is your n in this case? In your case,
for my formula, my n is
from n to what? To what number? To get the pi approximate, right? What is it? 15, 20, 100?
7271.
That's number?
Yep.
That's huge number.
Yeah.
Well, if you count my way, this just would be the half. Do you agree?
Yeah, I think so.
Because each time we count, yes, should be exactly half. Because each time I count 2.
Oh yeah, that's. Can I try putting the calculator? Like, just to be like. Wait, so you multiply -1 to the power of n plus 1.
Yes.
To the sum of the what do you call it? Oh wait, oh no, Dr. Young, we can't do a half because my assumption is that the value for n is a positive real integer, like it's a real positive integer. So half of that is not an integer because it ends in 1.
Oh, no, this is different formulation. We are talking about different formulation of general term, right? And it doesn't matter. Why should we go to the fraction? And we just, if we encounter fractions, so what we do if you got, say, if you go to 3, I don't know, what is this number divided by 2? 7, roughly.
3635.5.
3635. We just choose this
5.
one. We just choose this one.
Yeah.
That's
okay, let's try that. Yeah. -1 to the power of.
Now I'll tell you what. Why you are so conservative in this case? If let me see. If you publish the paper, no matter which professor publishes that paper, use this notation, right?
Yeah.
If uses this notation in the publication, right? And then I will publish a note just in reply to reply his you know, this notation looks ugly.
I mean, yeah, that is pretty fair. It is pretty
Now, if you're interested, we can go to more advanced in your spare time, not in your assignment. We can do something like how to use it. Do you know that the Riemann hypothesis?
No.
Not this
Riemann.
Riemann, yeah. This is all to do with. Let me see. Where did I put that reference?
Riemann. I've never heard of him.
One moment. I will find.
Yeah.
Change the page. One is the Euler.
Oh yeah, we use the Newton-Euler one.
Oh yeah, so I just show you something. So this guy is a great mathematician. Do you know him?
No. Riemann.
Yeah. And he has a hypothesis which remain unsolved. He has a hypothesis, and everyone can solve this problem, can get $1 million.
$1 million.
Yeah, and $1 million prize for his problem. The reason I mentioned him because that they are dealing with this series, including formula for the pi. So one of the formula relative, because you have your teacher give you a number of formula, but unfortunately they didn't give you anything relevant to Riemann hypothesis. Oh, for example, yeah, that's what I'm saying. For example, one of formula that is did by someone else. So that is a pi to the power 4 divided by 90 will equal to the sequences. So simple. That is n to the power of 4, sorry. So n from 1 to infinity. Have you seen this formula before?
No. 1 over. No.
And to prove this formula, you need to this kind of grouping. Okay, you need this grouping method. I just show you something. Okay. Now ask you the question. It's consider. So this is an example you can see how we group. How can we to group the series? Okay, is convention. Is there useful tricks to dealing with the to solve the mathematical problem? Okay, I tell you what.
Yeah.
So for example, if n, so this series looks simple, right? If n from 2 to infinity, okay?
Yeah.
How to prove of, we know it is a divergent. Do you agree? The word divergent, right? Or convergent.
Yeah.
Oh,
convergent.
You don't know.
Right.
Convergent or divergent is diverging. diverge, and converge. Which one do you choose?
For this formula.
Yeah, do you choose this one? Do you choose the second one?
This formula. Well, if 1 over n, that it approaches 1 over n means as you increase the values of n, it approaches 0.
Yes, each term will approach to 0. But how about the sum? For example, this is a 2 plus 3 plus 4 plus 5 plus until infinity. Okay. So what would be the sum of these two? You know the NA sequences formula? You don't, right? You can't. Because we only have learned two types of sequences. One is arithmetic, another is geometric. Okay.
Does it add up to like 1? Not 1.
Now, do you know do you need to know the answer?
Yeah, I'm not sure. I'm not really sure what it adds up to. I think it's probably something like it approaches to 1, but it doesn't. Oh wait, no. Well, half plus a third is. Does it add up to 2? Like, okay, yeah.
Do you know how to prove that? Do you know how to prove? Actually, I can tell you the result. This will be the result. It will diverge.
Diverge.
Do you know why? Here's the method. Now here's the method.
Yeah.
Okay, here's the method. So I think sometimes when you start mathematics, you should keep your mind open. All right, you will absorb new stuff. Okay, there's no fixed. There's no concrete. Especially you see something looks ugly. Mathematics look pretty and simple. So this we just consider about this one. So if you consider these sequences, if it's constant, when n equal to approach to infinity, does it inverge the sum? Every term is constant, half. Does this series diverge or converge?
Whoa. It's an infinite series, right?
Yeah, infinite. So n equal to infinity. So n approach to infinity. So what would be the sum?
Well,
you just use 0.5 times infinity. What is that?
Oh, half infinity of infinity, right?
It is infinity. Do you agree?
Oh yeah.
Because the reason we have struggling without a proof. We have struggling because each term getting smaller and smaller, right? Actually, every term will eventually, if a term is not enough, it will approach to 0, right?
Yeah.
By the way, do you understand this question? The question is whether these series diverge or converge. Converge means approach to 0.
How does it approach to? No.
I mean, your teacher have provided dozens of the formula, right? Except I don't know why. If I were your teacher, I would choose this type of we're more relevant to some of challenging question in mathematics.
Wait, does this series, when you add it up, approach 0? I thought it would approach 1 because like what?
No. The sum.
Oh.
The sum.
The sum of the series approaches 0.
I'm not talking about Tn. So Tn will approach to 0. Okay. Tn will approach to 0. Okay.
Yeah.
But I'm concerned about the sum. Okay, this is S for sum. Can you hear?
Yeah. Oh,
So
the sum will, yeah.
Okay. Do you agree now? So this is can we call this this is reference? Can you call it reference? Can you see? Can you call this a reference? Can you call S0?
Yep.
Right? Now let's kind of put this see, let's put this particular series in this equation. Can we rewrite this equation like this one? That will be 3 now. Can you see?
Yeah.
That'll be the 4. Can you see? After that, you go to the 5. Can you see?
Yeah.
And the 6, right? Right? 7. Just I will stop. I will stop at 8. Okay.
Okay.
Let's just continue. Do you agree?
Yeah.
Now, what is, because my question is, this is our reference. Okay, this is our reference or the benchmark. This certainly will go to infinity. Do you agree?
Yeah.
The sum, because there's if you time this one or you say it's half, that doesn't make any difference. It is still infinity. Okay.
Oh, yeah.
Now the trick is, if we just group them, so the group is very important. Can we group these two together? Can we
Those two
then
together?
group
Yeah,
these
okay.
4 together? What can we obtain?
Oh, what? Oh, if you group them together.
Yeah. So we still put the first term here. Okay, first term unchanged, right? We group them. We group them. Then we can and also that's how we group them. Okay. Can we just steps? Can we just go to can we do 2 things here
Yep.
together? Otherwise, we spend a lot of time. So the first term will be like this. Okay. By group them, in the meantime, I change one of them into 4. Can you see this is term 1, this is term 2? Okay.
All right, so you changed it into a quarter.
Yeah, a quarter. And then I will change everything into 8. Can you see the 8? How many 8? Of 1/8. Okay, 1/8.
4 of them. Yeah.
In doing so, does this get smaller or larger?
The summation, the entire summation?
Yeah.
Well, smaller.
Yeah, it is smaller. Do you agree? Because in these two, we replace 3 by 4. So therefore, these will be, so basically, do you know what? So basically 4 plus 4, I just write one of them, will be smaller than 3 plus 4. Or 4, do you agree?
Yeah, it's smaller.
And so does this one. So this does this one. If you call it, so that's why that's a group. That's very important. Can you regroup them? This called T1, T2, and T3. Can you see? Do you agree?
Yeah.
So what do we get? Compare with reference. How about this second one? Do you remember that? There will be our T1. This is a T2. So what is a quarter plus quarter?
Half.
Yes.
Oh.
Can you see? Can you see that? So this also this T3 is 2. So how about the 4 times 1/8? 4 times 1/8.
4 times 1/8 is also half.
Yes. So what sequence we get? If we call this, if this called T3.
Oh, okay.
What do you mean?
Okay.
Oh, so
it looks similar to the reference one.
So these will be, so all of these is unfinished. Okay, all of these will equal to S reference. Can you see?
Yeah, reference. Yeah.
So therefore, we can argue that this one will diverge because it is smaller than this sum. You see?
Yeah.
Because Sn is smaller or larger.
Well, it's smaller.
It's smaller.
Yeah, it's smaller. Yeah.
Oh, doesn't it didn't prove anything. It should be larger than that. Let me see. If we replace it by...
Wait a minute.
Yeah, it is smaller, right? It is smaller.
It's definitely smaller.
Which is smaller? Which is smaller?
Reference is a large number because half plus half is like 1 plus half 1.5. But then this one is, then Sn is smaller because it's...
Sn smaller, right? Smaller than reference.
Yeah.
Oh,
yeah, it is.
It doesn't prove anything. What's going wrong here? If you rewrite this form each term, and they will get to, yes, larger. Oh, no, it's other way around. Another way around. No. Can you see that? Can you see from here that if we replace this term, and this getting smaller, do you agree?
Yeah.
So in other words, okay, that is the key. So basically, what we can say, so Sn is smaller than S reference. Do you agree?
Yeah.
Because this inequality is here. All right.
Oh, okay. Yeah.
Because this sum is smaller than the sum, which is definitely will go to infinity or diverge.
Yeah.
So therefore, we choose the answer will be this one. Can you see?
Converge.
No, diverge. Sorry, diverge.
Yeah.
Diverge.
Well. Oh, okay. Because it approaches infinity. Yeah.
I mean,
yeah.
I use this example just to tell you that to group infinity term, the series with infinity term, that is a convention, is a standard. You know, this is one of the very useful method to do mathematics, right?
Yeah.
Do you understand how to prove this? Do you know how to prove this? Do you understand the proof now?
Yeah. So like to prove that this series is either divergent or convergent.
No,
like,
we have to we have choose one. Yeah, we have make it, this is uncertain. We have shown that this is divergent, right? Divergent.
Yeah, you got to prove it's divergent.
It's divergent. Yeah, we prove it's divergent.
Yeah.
I mean, this is a trick we use. The reason I mentioned this particular example is that in this case, you see,
yeah,
the reason I put these two terms together because it's easier, straightforward to dealing with the sign in front of each term.
Yeah.
Okay. You make a higher mark if you use this method.
Probably. It's just that
no, because it's wrong. I mean, in my opinion, this is wrong. There's no such a notation to dealing with negative and positive in the fraction. Okay, and tell people that hey, we choose these numbers. No.
Yeah. I'll probably just have to consider using this because I'll ask my teacher on whether we can use the round down or not, and if he says no, then this will be like what I have. This is
round down. Where did we round down? I'm just talking about the formulation of general term.
Yeah. But so you said that for whatever, so I got 7271 as my value, and then you said it would be half, right?
Yes, yeah, approximately half. Okay.
Approximately half. Okay, because
it's that point. Your number is not important. Seven, I mean, you can double check that because at that end, there's no difference. You can choose 7273 or 5. You know, doesn't make much difference because they are not the term of number is not that important because when you compare with different formulations, then you just pay attention to the order of the magnitude, not the exact. So, for example, these series are diverging or converging, around 100 or 1,000 or 1 or 10 millions. That is the order of number, order of amplitude we care, not the exact numbers. Right? Another thing, I don't know if you want to know, is that, do you know the second formula? The formula you have written into this form, so that is a 3 plus. Did you know how to get this? I can explain to you. Did you know how do they get this called continued fraction?
Oh yeah, that's our second one. I know how to get the iterations,
How?
but so it's like, so the first term is.
They just continue. Yeah, it just continue.
Yeah.
It's 292. Yeah.
Yeah. Oh, but in the continued fractions.
Yeah.
In our formula, we also use round down.
No, not round down. You have, the teacher will choose you how many decimal you go. Okay.
Yeah. Oh no. But like for the iterations of like each one, right?
Yeah.
The formula we have is so A0 equals
equal to 3.
A.
Equal to 3.
Yeah. Oh, because the way that we got each one of these is like equals this is what we were given, equals this.
The pi is an irrational number. You can't write pi. Pi have no finish. The number just continue forever.
Yeah. Oh.
So you for example, just to put it simple, can we assume you have how many decimal number? 1, 2, 3, 4, 5, 6, 7, 8. That is 8.
Yep.
Okay. Can we just assume that? How do we know? How do you know how this guy formulates this formula?
No, I'm not sure. We were just given the formula, and then we're given like how to calculate each number in the fraction, and it was using a like U1 minus U1.
Yeah.
Which would equal A2. Which would equal U2. No, sorry. Okay. So we were told the first one is A1 equals pi. You get basically you round it down to the nearest integer, and then you get 3.
Yeah.
And you get the second term equals 1 over 3 minus wait, what? Okay, no, never mind. I've done it wrong. I'll just rub it out.
I tell you what, I tell you my discovery, okay? My discovery is that this is a fake formula, okay? They did it is fake because, I mean, I call it fake, means it's unimportant because every number they obtained is come from the pi itself, all right?
Yeah.
So for example, to obtain the 3, so do you remember what is the closest fraction to pi?
22 over 7.
Yes. Okay. Can we rewrite the number of 21 plus 1 divided by 7?
Okay.
Okay. That will give you what?
Oh, yeah.
Give you 3. Can you see?
Yeah.
3 plus 1 over 7.
1 over 7.
Okay.
Yeah.
Now, if you use a calculator, that will give you at least 2 decimal, right? Correct.
Yeah, around 2, yeah.
So what is you can use a calculator. What is that?
Oh, you get 2 decimals, yeah.
2, 4, and after that, what's that?
2,
2?
8. Yep.
Okay, we just stop there. So basically, how do they fix this problem? I tell you what, this formula is not original. This formula is based on the number of pi. Okay.
Yeah, it is. Yeah.
It is not the original formula. So
Yeah.
if you rewrite this one, we know in that because this number is larger than pi. Can you see? It's larger than pi. So therefore, we must put something here. We added something. Can we say we added x here? Do you agree?
Yep.
So if this is the case, what would be the x? I tell you what, I will stop. I will stop here. Okay, 15. I will stop here, and then you know how do they obtain the rest? How do they obtain the 15? Okay, so basically, can we rewrite this formula? Can we rewrite this formula as so that is 1/7. Can you work out the x from your calculator? So just net how to you net pi equal to 3 plus 1/7x. Now in that way, that gives you exact number, right? Exact pi. If you use a pi, okay. Can we estimate x first? I think 0.006 or something. Can you find the x?
Oh, okay. Let me try and. No, okay. Like you put in the equation pi equals, and you gotta solve for x.
Yep. Using exact value for pi. Using exact value for pi on this side. Okay.
Oh, I'm sorry, but I'm not sure how to like put it in my calculator to make it solve for x.
No, you just type pi. You just pi. There's a key for pi. There is a key computer. It's called pi.
Okay.
Do you want me to show me to solve that? So that you have to solve. You solve x. How to solve x?
Oh, times
pi
okay. You
minus
can
3.
Minus 3. Yeah. Times
and
then
divide by x.
7 plus x.
Yeah. Right. Yeah.
1.
Right. Yeah.
So then
what is x about this number? X
divided by pi minus 3.
Oh, it's not that number. No, it's smaller. I think it's small. Yeah. What is x? Could you tell me what x is?
Yeah.
X squared equal to 1 divided by pi minus 3.
0.06. Yeah.
0.06. Anything else?
625.
625. Okay. So
in
other words, if we put this number here, we can solve this problem once for all. Do you agree?
Yeah.
But the author, the person who published this formula, he's very clever. He said, well, if we just manage to find the integers, if we just manage to find the integers, okay, whose fraction, so this fraction is approximately, but because it's they don't want to finish this series, all right? So if we just make a formula which is approximately but smaller, approximately equal to but smaller than this number.
Yeah.
Can you find the one?
So
can you find the integers? Yeah.
Sorry, is that what sign did you write? Is that an equal sign?
Oh, we just found the integer, but this integer is we use x. We use this fraction is slightly smaller than that one. When x is smaller, right, and that will be reduced. This number, can you see? This the original pi is 3.1415. Can you see? 15, right?
Yeah.
And without uses a correction, without added 6 here, we got the 28, right?
Yeah.
In order to approach this 15, we found x is approximately equal to this decimal. Do you agree?
Yeah.
But the author is smart. He said I'm not going to stop there. because I want to write the sequences. So
Yeah.
this just found what is the n is. If we choose n is integer.
Well, if you rearrange it, that means 1 over
x is
1
what?
over, yeah, is equal to 15.99.
5.19. 19, right?
99. No, double 9.
You can write it down from,
Yep.
we can write from your side.
Yeah.
Approximately.
Oh no, you gotta, yeah. Let me just draw it. Equals 15. Oh, whoops. I'll change that. My computer just froze. Sorry.
I just use calculator to help you. Just use calculator.
It's 15.99659.
Okay, approximately 16, yeah. Right? So
yeah.
in this case, you can either choose 15 or 16. All right.
Yeah.
If you choose 16, so we have to follow the logic. If you choose 16, what would be the reciprocal? If you put a 16 here, we just pretend. If you put a 16, what would happen?
Yeah.
What would be the result? Is this whole sum will be smaller or larger than pi?
Smaller than pi, because 1 over 16 is, I think it's a smaller number than 1 over 15, so it might.
So x is reduced, right? X is reduced, right? No. X is the increase.
X increase, but then pi is
X increase. The pi will be the result will be smaller. Do you agree?
Yeah, it's smaller. Yeah.
But if you do choose 16, what would be the result? Can you calculate the result?
Yep.
That is something very interesting, because you just thank you to tell me that you are dealing with this strange formula. But you see, sometimes you have found opportunity to learn, to explore, right?
Yep.
Don't think, I finish 80%. I mean, there's no end. If you've got a good, so what is the result? What is the result? If you choose 16, if you choose 16,
yeah.
Can you write here? Can you write here, please? Okay, they got how many correct? They got the four decimal correct.
1, 2, 3, 4, 5, 6.
Yeah.
5, 9, 2. Yeah, 1, 2, 3, 4, 5, 6. 6 decimal places correct.
Yeah. So, but unfortunately, this number is larger than pi. Do you agree?
Yeah, it is. It's slightly larger, but it's.
Now, in that case, it's too difficult to. So this guy is very simple. They're just trying to build these sequences so that the number will gradually approach to that one. Okay.
Yeah.
If that jump too high, that makes it impossible to do the fix, because they have to keep use the plus here. So he's very clever. So he, knowing that is the case, next time what he do, he just said, forget about this number. This is impossible. Okay. They just can say this, the two numbers, of course, cannot be integer because it's fraction. It is a fraction. Okay. You don't have to do this, but we basically know that will give a pi. The number, the number, the fraction, how to say, the quotient is so close to the pi.
Yeah.
As close as you like, by just increase the iteration. Okay.
But you have to choose the right integer, otherwise you overshoot. You go too far.
That's right. You can follow me now. I'm glad you can follow me now. So basically, that is how you end up with the choose 15 instead. All right.
15 instead.
Knowing that if you choose 15, it will be give the value which will be smaller than the pi. Do you agree?
Yeah.
Sorry, it's still larger than pi. Sorry, still larger than pi.
Yeah. No, it's still smaller than pi, but it's getting closer.
Getting closer, right?
It's smaller. The other one's larger than pi.
Can you see that the three terms show up? 3, 7, 15 show up?
15. Yeah, I understand that now. Yeah.
So if you that is I don't know, we have talked about, do you know this Euclidean? Have you heard of Euclidean?
Euclides was like a
Algorithm.
Greek mathematician.
Yeah. Algorithm. Have you
Euclidean.
Euclid? Do you have heard of Euclidean algorithm?
I think you mentioned it, but I don't. It's not one of our things. We have.
So basically, they are searching for the greatest common
Yeah.
dividers of two numbers.
Okay.
So what do they do? For example, if you have so for the 12 divided by say by 6, all right? So
Yep.
what is in this case is simple. So we just you can either write 2 times 6, all right? Or you can write as in this case you got let's just write it another way. How about 3 times 4? That's 3 times 2, right?
2.
And of course you don't do anything. You just write 1 times 12, 1 times 6, right?
Yeah.
The common divider is such. So this is a common divider. Can you see? Can you see the common divider here?
3, 3, and then 6.
Okay. So in this particular simple example, that the GCD 12 and 6, sorry, not 10, but 12 and 6 were equal to what?
6.
That's right. That's right. So 6 is the greatest, right?
Yep.
So that is a simple. So Euclides, long time ago in ancient Greek, and he found the formula for that. So basically, if you're looking for the two integers, say a divided by b, right?
Yeah.
So basically, he could rewrite it as a equal to b times q plus r. So
Yeah.
this is called the division algorithm. It's called the division algorithm. This formula, okay, it's just rewrite the division. So this is q for the quotient. Have you heard of quotient?
Yeah, it's like the when you divide, you get the
This is divider. So this is divider, right? The divider. This is D for divider. That's a D for divider. Now he invented, of course, in general, for example, given this 328, right, divided by 32, right? So for
32.
example, you can try this one. Of course, if without use this method, without using Euclidean algorithm, you will take hours, even days to get this answer, right?
It's 8, 16. It's one of those, right?
Oh, you can. For example, you can try. You can try to find the. It is just an arbitrary number.
Oh, whoops. Yeah, let me just fix that. Sorry. Yep.
Now, I think we'll stop there. I will just demonstrate how to do that. Okay. So the method he used is that if you put this can we call this 1, because this is just continuous. So he's very clever. He first put the b here and put the b here, and in this case they use the R1 as dividend, and to get another quotient, and then obtain another remainder. It's called remainder. R is a remainder.
Yeah.
Remainder. Have you studied remainder? Yes.
Yeah, like we did division of polynomials and all that.
That's right. Yes, that's remainder. Yes, that's come from this form. It's come from this form. Yes, same. This is number. Okay, this comes from number. So they just in this case they just go on. So you just shifted R1 here, and put this. You put in this case put the second remainder here, and found the quotient and the remainder. Can you see?
So it's just remainders.
Yeah,
like you keep.
Yeah, this just go on forever. So this go on forever. Of course, at a certain stage, it will stop. Okay, if you stop. So basically, by the time they found say n, so in this case that is if this remainder equal to 0, so can we?
Then it stops.
Can we? They will got answer. You got this result. So basically, you got so that is how to figure it that. So this is how to say, this n minus 2, right? N minus 2, and this is n minus 1.
N minus 1 and then Qn.
That's Qn, right?
Yeah.
That's Qn. So that's Qn. So if
Yes,
that
right.
so okay, if Rn equal to 0, then he said the greatest common divisor of A and B were equal to Rn minus 1.
Oh, okay. That makes sense. Rn minus 1.
Yeah. Now, if you have time, I think you will. Can you rewrite this formula? Okay. Into this form. So how about say from this formula? Okay, I just give you 5 minutes extra. Say A divided by B will equal to Q1 plus R1 divided by B. Do you agree? From the first formula.
Okay.
That's from second. Yeah. Do you agree?
You just divide everything by B. Yeah.
Yeah. From the second formula with B divided by Q2, right?
Yep.
We're equal to what?
R1.
No, divided by R1, sorry, R1.
Oh, okay.
R1.
Equals Q2 plus
Q2
R2
plus
over R1.
R2, R1. Can you see?
Yeah.
You divide R1, okay. Okay, that's enough. If we combine these two formulas together, what do we get? We got this A divided by B, we're equal to Q1 plus, now we put this R1 upside down, okay? That equal to B over R1, can you see? This is B over R1, can you see? Can we substitute that one? So that's Q1 here, right? Then you got the Q1 plus, what is B1, but what is B over R1? That is Q2, can you see?
Oh,
Q2 plus, can you see? That's how, that is Q2 plus R2. So that we just write it as a fraction. We just rewrite it as R1 over R2. Okay?
Okay.
So if you go this one, then that will continue. So that is exactly the format, exact form of the what we call the continuous fraction in your assignment.
Oh.
Can you see that? So that's Q2, and it's Q3, and it's Q4, and they just continue.
So this is where the continuous fractions basically.
This is basic continuous function originally come from.
Oh.
So this guy, I don't know his name, whatever. This guy obviously he knows that how to use this continuous fraction. You understand?
Damn. Yeah,
well,
makes sense.
No. I think if you want, why don't you? Because this is, you can put our discussing into your report. That's my recommendation. You can make a remark that this formula, I wouldn't call it fake, but it's very clever way to rewrite pi. Okay.
Rewrite pi.
It gives impression that if you follow these sequences, then you can obtain the pi, right? But actually, if you can make such remark in your report, in your assignment, I think your teacher will be pleased. All right.
So what? So what do I remark on? Do I just say
this particular form, so-called formula, all right, is simply rewrite pi.
Yeah.
In the form of Euclidean's division algorithm.
Euclidean.
Yeah.
Okay. Yeah. Oh, that makes sense. Okay.
Okay. Remember that. Remember that.
Yeah, I'll write that down. No, that's yeah.
So if you because you are in year 11 now, you are not just finish. You finish. Everybody thinks that is a correct or accepted answer. You have to show your own independent thinking. You understand?
Yeah.
So in this case, if you can, for example, you are only one in your class to understand that this underlying story.
Yeah.
Then that would be marvelous. Do you agree?
Yeah. But the only thing I have with that is that apart from, I'll just have to see how, okay, so all I have to, okay, yeah, no. I have to include it. I just could think where I can include it. Okay.
No matter what you do so far, 80% or 85%, it doesn't matter. You are ultimately, you're going to write a report, right?
Yeah,
You're
yeah.
going to write the word, 200 word, 2000 word, how many words?
There's no word limit, just 10 pages.
Oh, that's normal. 10 pages, not a thing to, not a story to talk, right?
Yeah, I've done
If you
8
can,
pages. Yeah.
if you can, you know, incorporate this background into your report, and that would be very interesting, including
Yeah,
the
I
first
know.
one. Including the first one. I mean, including the first one. Why don't everyone have to use the same, same answer? Why does everyone must have same answer? You know what I
Not
mean?
every.
You mean
Yeah, I see. Yeah.
don't be so conservative. You're a young boy. If you use this one, I'm sure you will get a higher mark because you are doing something independent. You are
Yeah.
seeing different from the rest of the classmate. You see.
Yeah.
Now, by the
I'm not.
time when were your assignments due? Is due.
I think. I'm not sure. I know it's not next week.
You can email
At
me.
least.
You can. Did you use Word or other software?
Word.
Yeah,
Word.
you can
Yeah.
email me. I will give you some remarks. We can discuss.
Yeah. It's just that um I like I see like this formula that you found for the for the combination fractions is good, but the only problem is I've I've just gone like I've done like so much with this
No,
formula
no,
and
no,
I've
no,
already like
no. You're not a businessman.
yeah, but
I tell you what. Knowing that the number would be, if you knowing the fact, the formula uses this formula, the number will be reduced by half. So what's the point to use the 7,000? If you can get that approach to your divergent to the required accuracy,
yeah.
why should we go to 7,000?
Hmm.
Don't be too calculated when you study something. And I tell you
Yeah,
what, sometimes people just spend hours without any outcome.
yeah.
Studying subject is not doing business. Forget about your cost.
Oh, okay. All right.
All right.
But I have a just a quick question before you go. If it even if it's the same formula, but it produces a different answer because it groups it together, that's why like it won't be 7,271, right? It'll be because you group two terms together. That's why like that's why I produce a different answer,
Oh,
right?
by the way, do everybody must have the same answer in the group?
Uh yeah, basically.
What do you
Because
mean basically?
that you're given there are people assigned, you know how
I
you're
know.
assigned
I know
yeah,
the sign to the group people to have the same accuracy. Okay, say the S or ninth decimal, right?
yeah,
But every individual is entitled to choose the way to answer the question.
yeah, that's fair.
Shall we stop here and you think about it? Okay.
Yeah, yeah, I'll
Okay.
see.
Okay.
All right then.
Okay.
Goodbye.
Goodbye.
Uh